So in this video, I'm going to go over the review for test number 2 from fall 2018. So this wasn't actually a test, it was a review for a test. But it had a lot of similar characteristics, so there's a lot of good practice on this one as well. All right. But you might find some of the questions here to be a little bit more elaborate than what you might find on the test. The first 2 questions were fact-based, just like the last 2 videos. They just are, so I just denoted them there. So we're just going to jump right to number 3. I took the liberty of typing that into the calculator already. So stat edit. All right. Since it's basically the 3rd video doing the same thing, you know, there's a lot of things that I'm going to just kind of trim out. Right, in terms of instructions, just more like what do you do, not so much how you do it. All right, so data is typed in theory correctly. I'm just going to give it another quick look. What I'm going to do is stat, let me quit out of here, stat calc option 1. Data is in L1 and L2. If not, make your calculator say that. And I'm just verifying that the n value is equal to 1. Right? It says assume that the following is a probability distribution, so that makes it a little bit easier. I don't have to worry about it not being. The mean is 2.89, and the standard deviation is equal to 1.476, if rounded correctly. Number 4, a die is rolled 7 times. What's the probability at least one of those rolls turns up a 4? 2 ways to handle this, again, is the table approach. So we could use, I'm going to just jot down table approach, and then I'm going to do the work on the calculator. So you'll follow along with that. Stat edit. We're rolling it 7 times. So that means we could have as many as 7 successes. So no success all the way up to 7 successes. Let me wipe out what I have in L2. Now we're talking about a die here. We want to know that the probability at least 5 of those rolls turns up a 4. All right, so go right onto L2, hit enter, second vars, Binom PDF, 7 trials, 1 in 6 chance of success, because again, it's a die, not a coin. All my possible successes are found in L1, hit enter. Now in this case, I'm just looking for at least 5, so that's 5 or more. All right, so 5 or more. All right, so I'm just gonna do a quick copy paste job here, just in case I screw this up. So I don't want the 0th, 1st, 2nd, 3rd, or 4th. I only want the 5th, 6th, and 7th. So I'm just going to verify that that happened. So starting at 0.0019, 0.0001, and 4. Yep, okay, looks good. So then I'm going to quit out of here. I'm just going to jot down here that I'm looking for the probability of 5 successes, or 6, or 7. I'm going to do second, stat, math 5. The list I want to find the sum of is list 3. I'm going to close it up and hit enter, and I'm going to get about, well, if I'm going 3 significant, it would still round to 0.002. All right. Now, if I'm using Binom CDF, this is at least. Binom CDF does at most. All right, so what I would do first, if I want probability at least 5, I would do 1 minus the probability of at most 4. All right, so 1 minus Binom CDF. Then I would type in the 7, the 1/6 and the 4, because that's our at most number. All right, so 1 minus second vars binom CDF 7 comma 1/6 comma 4. And we get the same value, so we know we're in good shape. More than that, we know that we did it right. Oh, more than good shape. We did a great job. Number 5, an inspector samples a selection of 1,500 CDs. The probability of defect is found to be 0.18. Assume that it's a binomial distribution. Determine if 75 defective CDs would be considered unusual. All right, so I need the mean. $1,500 times 0.18. Talking about 270. Square root of NP Q. Now Q is the same as 1 minus P. So 1,500, 0.18, 0.82. Well, it would round to 88. So I need now mu plus or minus 2 sigma to give me my interval. So 270 minus 2 times 14.88. And then same thing, just with a plus sign. So second enter to recall. And then second delete. So delete the value, the minus sign, then second delete to insert the plus sign. So we're looking at 240. Oop, poor quality 0. 0.24. And then 299.76. These are our usuals. Therefore, 75 is unusual. Does not fall in that interval. It's not between the numbers 240-ish and 299-ish. All right. So first 5 questions in the books. Number 6, just like in the last video, these expected value questions, we saved this for a tech assignment. We'll talk more about that after the second unit test. So that's tossed. Number 7, we want to know the probability of a person being in the marijuana category, given that they're in the 26 or older category. So our given is 26 or older, so that puts us in this column of the table, and all I care about are the marijuana users in that column. So we're looking at, I'll just jot it off on the side here, 1378 out of 2583. And that's it. Those contingency table questions are the easiest ones. All right. I mean, to come up with an answer. They're also very unforgiving if you screw it up, so take your time and be careful. Tree diagram or list of sample space for 2 tosses of a coin. All right, so coin 1, heads, tails, coin 2. For each one of those heads, we get a heads or tails, or for the heads we get heads, tails. For the tails, we also get a heads, tails. Followed by the roll of a die. So roll of a die. So it's going to get ugly. So that's one of them. Then we got to get 6, 6. 1, 2, 3, 4, 5, 6. Yeah, they get very ugly very quickly, and so you just kind of do the best you can. Right? That's why I tend to want to go with the sample space, because then it's just a matter of listing out all the possible ways in which you can come up with the different outcomes, and that's really the end of it. All right, so in this case, it's heads, heads, so sample space, heads, heads, 1, then heads, heads, 2, 3, 4, 5, and 6. Then heads, tails, and the same thing with tails, tails. And then finally after that, tails, heads. Definitely a little bit more organized. Handwriting is still crap, but it's a little bit more organized than the tree diagram, as you can see. I mean, look at the disaster on the left, and it's a little bit less disastrous on the right. But yeah, it does take a little doing. Number 9, 3 cards are selected at random from the following set without replacement. What's the probability that they're all clubs? Well, I have a total of 1, 2, 3, 4, 5, 6, 7 cards, half of which are clubs. Those are the black cards. So 7 out of 14. Then we're selecting 3 of them without replacement. So if I select one of them at random, then any of the 6 remaining cards would be clubs out of the 13 overall. And then if I select another one at random, any of the remaining 5 clubs would be possible out of the 12. So 7 times 6 times 5, talking 210, over 14 times 13 times 12. It's not a 12. 2184. And it would simplify somewhat. You know, not the most neighborly looking fraction in the world, but not a terrible one either. So let me get rid of the equals because it's either or. All right, expect the problem that's going to have to ask you to put your answer in fraction form, not decimal form. But I don't care what form your fraction is in. All right. Just like the last one, there's a bonus problem that we're going to toss because we're going to handle bonus differently in this course. And also the permutation question is out. So number 10, 2 cards are selected at random from the following set without replacement. What's the probability that they're all either clubs or threes? All right, so let's go through and take a look. So only 2 cards this time. Clubs. I'm gonna use a highlighter here. Here are my clubs. And I also want the threes. So instead of it being 7 out of 14 now, it's going to be 8 out of 14 because there's 8 cards that are good to go. All right, so 8 out of 14, and really this should say both. So once I select one of them, I only have 7 left out of 13. So 56 over 14 times 13. Oh, 14 times 13 hit the wrong key. $1.82. Both even, so it'll reduce. Four out of 13. Last and final. How many events are in the sample space for 9 rolls of a fair die? So number of outcomes for 1 roll, 6. Number of rolls, 9. Then 3 flips of a fair coin. Number of outcomes for 1 flip, 2. Number of flips, 3. So 6 to the 9th times 2 to the 3rd. And we're looking at this monstrosity. 8062158. All right. So never would consider drawing a tree diagram or listing a sample space for this particular set of outcomes. And there it is.